Before we wrap up these 7-4 notes with our last couple examples, let's talk about what 7-4 was about yesterday. We talked about 2 new ways to show that triangles are similar to each other. Who can tell me one of those ways? Side, side, side. So one way that we talked about proving triangles similar, I'll just start a list over here, was side, side, side. And that meant that the sides from both triangles, corresponding sides, were proportional. So corresponding sides were proportional. That's one way to tell that 2 triangles are similar. All right, what was the other way we talked about yesterday? Side, angle, side. In this case, sides were proportional and angles were the angles. Sides are proportional.
Congruent.
Wonderful. Sides are proportional. Angles are congruent.
Yes.
Okay, that's a recap of what we talked about yesterday. Also with side, angle, side, remember the angle has to be in between the sides that we're talking about. All right, that was a wonderful recap. So let's keep it going with example 5. We are asked to show that these 2 triangles are congruent to each other. Triangle VYZ, so that's the large triangle, and also triangle VWX, the smaller triangle inside of it. Now, on other problems like this, sometimes we had sides being marked as parallel, but we don't have that here, so we cannot assume it. At least not yet. We'll learn something else next week about that. Okay, so we cannot assume anything about having parallel sides. So what happens if we draw these triangles separate from each other? So if this triangle is VWX, what's the side length of VW? 4. And the side length of VX?
5.
Is 5. And we don't know anything about the other side length, so we'll leave that blank. Let's also draw our larger triangle, which is VYZ. What's the side length of VY? 12. How'd you get that? You add them together. If they tell us both pieces, we can add them together to get the whole side length. So we know that that side has a length of 12. All right, what about the other side? VZ is going to be 15. Which angle is going to be congruent between these? Which angle? V. Okay, so V is exactly the same angle in both of them. We drew over it twice. In the top triangle, we might call it angle WVX. In the bottom one, we might call it YVZ. But either way, that's the exact same angle that came from the very top of those triangles. So we know we've got a congruent pair of angles. So now we just need to show that these side lengths are proportional. Okay, so what's the longest side in our small triangle? 5. And we would compare that to what side in the other one? 15. That would simplify to give us 1/3. What's the other side length from our small one? 4 over 12 simplifies to 1/3. So would we say that these triangles are similar? They're definitely not congruent, but they are similar. Okay, so we could say similar by which property or which theorem?
Side.
Good. Side, angle, side. So when it says to show that two triangles are similar, that's kind of a broad set of directions. But you need to write down that you have congruent angles. So you either have to make a congruent statement, mark it in the picture. Somehow you have to tell me that you know those angles are congruent. And then you also need to show me your ratios of your sides. Now, if you went big to small instead, and you got 3 over 1 instead of 1 over 3, that would be fine, as long as you get the same ratio and you show that those sides are proportional. All right, on number 6, we're looking at these two triangles, similar to number 5. It's just turned a different way. I drew the triangles separately, not a requirement, but I think it's helpful. So let's label our triangles. What can I label LM? 16 and LQ. 14. What about LN? 56. Okay, we added these two together to get 56. And what about LP? 49. So again, we add the two sides, two segments together to get the whole side down at the bottom there. So we added those together. All right, which angle is going to be the same in both? Angle L, that's the one that they have in common that we would have to draw twice. L is there both times. So we know we've got a pair of congruent angles. So now we just need to check to make sure our sides are proportional. So we would compare LM, or 16, to which side from the other one? 56. Okay, I think that can reduce. What would that reduce to? 2 over 7. Okay, both divisible by 8. And then we would also compare 14 to 49, and that reduces to also 2 over 7. So we have a pair of congruent angles, and we have two pairs of proportional sides. So are these triangles similar? Yes, by which theorem or postulate? Side, angle, side. So we would say similar by side, angle, side. Last example for this section, number 7. Again, we're trying to, well, in this case, we're trying to determine if these two triangles are similar. So the last couple, they told us to show that they're similar. That implies that they definitely are similar. We just kind of have to prove it. Here, we're deciding, are these similar or not? So not similar is an option in this case. All right, what's one thing we notice about these triangles that is important? We got right angles in both of them. So we definitely have a pair of congruent angles. We could mark them with an arc also if we want to. Those angles are definitely congruent because all right angles are congruent. So then we need to figure out if the sides are proportional to each other. So I should compare the side length of 12 from my big triangle to what side from my small triangle? 8, good. Why did we use 8 instead of the 6? The bigger one. 12 was the bigger side, 8's the bigger side. So we got to pair those up. 12 over 8 simplifies to be 3 over 2. Wonderful. Okay, that's as much as we can reduce that one. So then we move on to the other pair. So we would use 8 over 6. That reduces to 'What can we divide these both by? 2. 8 divided by 2 is 6 divided by 2. Are these triangles similar?
No.
No, why not?
Because I ain't similar. They have the same scale factor.
Okay, that's one way to say it. They don't have the same scale factor for those sides. Okay, the sides are not proportional is another way to say it. Okay, you can say it any valid way you want to. So, not similar, sides are not proportional. So don't get in such a habit of them coming out to be similar that we don't legitimately check to make sure that they are. Okay, don't get too excited over it. Any questions about 7.4 at all? All right, then that wraps up the notes.